Okay, so what if I told you that there's a way to make AI like dramatically more energy efficient without having to sacrifice performance?
Right.
And not like in some far off future, but like right now.
Yeah.
That's what we're diving into today.
Yeah, that's right. We're talking about a breakthrough algorithm called L-Mul.
Okay.
And it's tackling one of the biggest problems in AI today.
Okay.
The energy consumption of those massive neural networks that we keep hearing about.
You know those large language models or LLMs like ChatGPT?
Exactly.
The one everyone's using to write poems and argue with?
Yeah. Yeah.
Turns out those things are energy hogs.
Big time. Yeah. Imagine this.
Oh, boy.
A single day of running ChatGPT uses the same amount of electricity as 18,000 U.S. households.
Wow.
That's a lot of power, and it's all because of the way these models do their math.
Okay.
They rely heavily on something called floating point operations, especially multiplication, which are very energy intensive.
Floating point operations, that sounds kind of technical.
Yeah.
Can you break that down for us a little bit?
Sure. Think of it this way. Floating point numbers are like really precise measurements with lots of decimal places. They're great for complex calculations, but they require a lot of energy to process. It's like using a giant, super accurate scale to weigh a grain of rice. You get the exact weight, but it takes a lot of effort.
Right. Okay. So we've got these power-hungry AI models doing a ton of these floating point multiplications.
Right.
And that's where L-Mul comes in.
Exactly. L-Mul is a clever algorithm that can replace those energy-intensive multiplications with something much simpler and more efficient integer additions.
Wait, you're telling me we can just swap out multiplications for additions and everything works fine?
Pretty much, yeah.
That sounds almost too good to be true.
I know, right? But the research shows it actually works.
Wow.
L-Mul achieves this by cleverly leveraging the way floating point numbers are structured. They have two main parts. A mantissa, which is like the main number. And an exponent, which tells you how big or small that number is.
I vaguely remember mantissas and exponents from high school math.
Right.
Maybe a quick example would help.
Sure. Think of the number 1.2345.
1.2345.
1.2345. The 1.2345 part is the mantissa. And because the decimal point is right where it should be, the exponent would be 0. But if you had a number like 1234.5, the mantissa would still be 1.2345. But the exponent would be 3. Because you've moved the decimal point 3 places to the right.
Right. Okay, so L-Mul does something clever with these mantissas and exponents.
That's the ingenious part. Instead of actually multiplying the full floating point numbers, L-Mul just adds the mantissas together and then adjusts the exponent using a specific formula.
So it's basically finding a shortcut, getting a really close approximation of the answer without having to do all the heavy lifting of a full multiplication.
Exactly. And the surprising thing is this approximation is so good that it actually works incredibly well in practice. In some cases, it even outperforms traditional floating point operations.
No way. So it's not just about being energy efficient. It's actually better in some ways.
It can be, yeah.
Tell me more about these results.
Well, they tested L-Mul on all sorts of benchmarks, including GSM-8K, which is a set of grade school math problems and visual question answering tasks. And across the board, L-Mul was either on par with or even slightly better than the standard floating point methods.
So this isn't just theoretical. It's been proven to work in real-world scenarios.
That's what makes this so exciting.
Yeah.
They even tried swapping out L-Mul in the attention mechanism of transformer models. Which is like the brain of many LLMs.
And did it mess everything up?
Not at all.
Wow.
It either performed the same or even slightly better. The researchers were even able to fine-tune models with L-Mul replacing all the multiplications. And they worked just as well as models trained with the standard floating point operation.
Oh, no, that's huge.
Yeah.
If we can train models specifically for L-Mul hardware, that opens up a whole new level of possibilities, right?
Absolutely. But before we get too ahead of ourselves, let's dive a little deeper into the specifics of how L-Mul actually pulls off this magic trick. How does it achieve this remarkable precision using such a simplified approach?
That's what I was wondering. You mentioned something about 4-bit and 3-bit mantissas earlier.
Yeah.
What's the deal with that?
The size of the mantissa actually plays a key role in the precision of L-Mul. It turns out, even using a 4-bit mantissa, L-Mul can achieve comparable accuracy to standard 8-bit floating point operations.
So it's doing more with less.
Right.
But what about that 3-bit version?
That's where it gets even more interesting. The researchers found that L-Mul with a 3-bit mantissa actually outperformed one of the standard 8-bit formats.
Wow.
We're talking about better performance with significantly less energy.
This is blowing my mind. We're talking about a potential paradigm shift in how AI computations are done.
It really is.
But before we get lost in the technical weeds,
Right.
let's pull back for a second and talk about what this actually means in the real world.
Okay.
I'm thinking about things like training even larger models.
Sure.
Bringing AI to devices with limited power.
Yep.
Maybe even making AI development more sustainable in the long run.
All of those things, yeah.
Yeah, this is huge.
But there's one area in particular where L-Mul's impact could be truly revolutionary.
Okay.
The attention mechanism, that brain of many modern AI systems.
Okay, I have a feeling this is where things get really interesting.
It is, the attention mechanism is notoriously energy intensive.
Right.
But it's also absolutely essential for many AI tasks.
Mm-hmm.
And the researchers found that L-Mul can be seamlessly integrated into this mechanism without any performance loss.
Wow.
And in some cases, even improving it.
No way. So we're not just talking about making AI more efficient.
Right.
We're talking about making it better.
Right.
While simultaneously reducing its energy footprint.
Yeah, that's the incredible potential of L-Mul.
This is wild.
But before we dive into all the amazing possibilities,
Okay.
let's take a closer look at how L-Mul handles that tricky business of mantissa addition and exponent adjustment.
Okay, back to the technical details. You mentioned something about carryover earlier. I have a feeling this is going to involve some flashbacks to elementary school math.
It might remember how when you add numbers like 5 and 7,
Right.
you get 12 and you have to carry the 1.
Right, yeah.
Well, L-Mul cleverly uses the same concept
Okay.
to handle the carryover from the mantissa to the exponent.
So it's like L-Mul has a built-in assistant that takes care of all the tedious bookkeeping,
Kind of,
making
yeah.
the whole process smoother and more efficient.
Exactly. It streamlines the entire process, taking advantage of the natural way integer addition works.
Gotcha.
And it's this elegance and efficiency that makes L-Mul such a groundbreaking discovery.
Well, I'm definitely on board with the L-Mul hype train now.
Yeah, me too.
But before we go full steam ahead, I want to pause for a moment and think about the bigger picture.
Okay.
We focused a lot on the technological aspects of L-Mul,
Right.
but what about its impact on society as a whole?
That's where things get really interesting.
Hold that thought. That's a perfect cliffhanger to end part 1 of this deep dive.
Okay.
We'll be back in part 2 to explore those implications and the potential future of L-Mul.
Sounds good. We left off talking about L-Mul's potential to reshape the future of AI.
Yeah, you had me hanging on the edge of my seat with that cliffhanger.
Yeah.
What kind of possibilities are we talking about here?
Well, imagine training AI models so large and complex that they dwarf anything we have today.
Okay.
Models capable of truly understanding and responding to natural language.
Okay.
Creating art that rivals human creativity.
Wow.
Or even cracking some of science's toughest mysteries.
It's like upgrading from building skyscrapers to constructing entire meganacities in the world of AI.
Yeah.
But right now the energy consumption is like trying to power those cities with a handful of windmills.
Exactly. But with L-Mul, that energy barrier starts to crumble.
Okay.
We could build those AI megacities without needing a power plant the size of Texas.
So it's not just about the size of the models.
Right.
It's about accessibility too, right?
Yeah.
Not everyone has access to a supercomputer.
Absolutely. Right now, running sophisticated AI models requires a ton of expensive hardware and electricity. But with L-Mul, we could potentially run those same models on devices as small as a smartphone.
Okay, now you're really blowing my mind.
Yeah.
AI, that powerful, running on something I can carry in my pocket.
Right.
That opens up a whole new world of possibilities.
Think about personalized AI tutors that adapt to your learning style.
Okay.
Medical devices that can diagnose illnesses with incredible accuracy, or even AI-powered tools that can help us tackle climate change by analyzing massive amounts of environmental data.
It sounds like we're talking about a future where AI is no longer this exclusive tool for researchers and big corporations, but something that everyone can benefit from.
That's the exciting part.
Yeah.
L-Mul could democratize AI, making it more accessible and affordable for everyone.
Well, let's be realistic. There are bound to be challenges along the way. It can't be as simple as just flipping a switch and suddenly all our AI is running on L-Mul.
There are technical hurdles to overcome, especially when it comes to hardware. Right now, L-Mul is mostly implemented in software, but to really unlock its full potential, we need specialized hardware that can run those integer operations with maximum efficiency.
So it's like having the blueprints for a revolutionary new engine.
Yeah.
But we still need to build the actual engine itself.
Exactly. It's going to require collaboration between researchers, chip designers, and hardware manufacturers to create those specialized chips that can truly take advantage of L-Mul's unique capabilities.
But it sounds like those efforts are already underway, right?
They are. And on the software side, developers are working on creating APIs that will make it easier to integrate L-Mul into existing and future AI applications.
So it's a two-pronged approach, tackling both the hardware and software challenges in parallel. But even if we solve those technical hurdles, there's still the question of adoption, We need people to actually use this new technology.
That's a crucial point. We need to convince developers, businesses, and policymakers that L-Mul is worth investing in. We need to demonstrate its benefits, provide the tools and resources to make adoption easy, and address any concerns or skepticism that might arise.
It's like launching a new product.
You
need a killer marketing campaign, excellent customer support, and a clear value proposition to win people over.
And luckily, L-Mul has a pretty compelling value proposition.
Okay.
It offers significantly lower energy consumption, comparable or even better performance, and the potential to unlock a whole new era of AI innovation.
It's hard to argue with that, but let's shift gears for a moment and talk about the bigger picture. We focused a lot on the technological aspects of L-Mul. But what about its impact on society as a whole?
That's where things get really interesting. The widespread adoption of L-Mul could have profound effects on the way we work, communicate, learn, and even how we address some of humanity's biggest challenges.
Let's start with the workplace. How could L-Mul change the way we work?
Well, as AI becomes more accessible and affordable, we can expect to see a surge in automation across a wide range of industries. Tasks that were once done by humans could be taken over by AI systems, potentially leading to increased efficiency and productivity.
But that also raises concerns about job displacement,
Sure.
If machines can do our jobs faster and cheaper, what happens to us?
That's a valid concern, and it's something we need to address proactively. As with any major technological shift, there will be winners and losers. Some jobs will inevitably become obsolete, while others will transform, requiring new skills and expertise.
So it's not just about embracing AI, it's about preparing for the changes it will bring and ensuring that everyone has the opportunity to adapt and thrive in this new landscape.
Exactly. We need to invest in education and training programs that equip people with the skills they need to succeed in an AI-powered world. We also need to explore new economic models that can ensure a fair distribution of wealth and opportunity, even as automation reshapes the job market.
It's a complex challenge, but one that we can't afford to ignore. But beyond the workplace, L-Mul could also transform the way we communicate and interact with the world around us.
Imagine a world where language barriers are a thing of the past, thanks to AI-powered translation tools that can understand and translate languages with incredible accuracy. We could communicate seamlessly with people from all over the globe, fostering greater understanding and collaboration.
Like that universal translator from Star Trek becoming a reality.
Exactly. We could also see a shift in how we consume information and entertainment. AI-powered systems could curate personalized news feeds, recommend books and movies based on our individual tastes, and even create custom-made music and art.
It's a world of endless possibilities tailored to each individual's unique preferences and interests.
But with this abundance of personalized content comes the responsibility to be discerning consumers. We need to be aware of the potential biases and limitations of AI systems and ensure that we are not simply living in echo chambers that reinforce our existing beliefs.
It's about using AI as a tool to expand our horizons, not narrow them.
Precisely. And ultimately, the most profound impact of L-Mul could be its ability to help us solve some of the most pressing challenges facing humanity.
I'm thinking about issues like climate change, disease outbreaks, and global poverty.
Exactly. With more efficient AI, we could develop systems that can analyze vast amounts of data, identify patterns, and make predictions that can help us address these complex problems.
So instead of being overwhelmed by the scale and complexity of these challenges, we could leverage the power of AI to find solutions and create a better future.
Exactly. But as we've discussed, there's another side to this coin.
Okay.
Along with the potential benefits of L-Mul, there are also potential risks that we need to consider.
You're right, and that's where we'll pick up in part 3 of this deep dive. We'll explore some of the potential downsides of L-Mul and what we need to be mindful of as this technology continues to evolve.
Sounds good.
So we spent the last 2 parts of this deep dive really exploring the incredible potential of L-Mul, this algorithm that could totally revolutionize AI by making it more efficient and accessible. But as with any powerful technology, we need to think about the potential downsides.
Of course,
and risks,
It's like handing someone a supercharged chainsaw.
Right.
It can clear a forest in record time, but it can also cause some serious damage if it's not handled with care.
So what are some of the specific risks we should be thinking about with L-Mul?
Well, one concern is the potential for bias and discrimination.
Okay.
Remember, AI systems learn from the data they're trained on.
Right.
If that data reflects existing societal biases like gender or racial inequality, those biases can be amplified and perpetuated by the AI.
So if the data used to train an AI model contains examples of, say, loan applications being unfairly denied based on someone's race, the AI might learn to discriminate in the same way.
Exactly. And because L-Mul is designed to be integrated into existing AI systems, it could inadvertently inherit and amplify those biases if we're not careful.
That's a disturbing thought. We don't want AI to become a tool for perpetuating injustice.
Absolutely not. That's why it's crucial to be incredibly mindful of the data used to train AI models and to develop techniques for identifying and mitigating bias.
Right.
It's a challenge that requires collaboration between computer scientists, ethicists, social scientists, and legal experts.
It sounds like a complex problem with no easy solutions, but it's one we can't afford to ignore.
Definitely.
What other risks should we be aware of?
Another concern is the potential for misuse.
Okay.
As AI systems become more powerful and accessible, there's a risk they could be used for malicious purposes.
I'm picturing things like deepfakes being used to spread misinformation. AI-generated propaganda influencing elections. Or even autonomous weapons systems making life or death decisions without human oversight. That's pretty scary stuff.
It is. While L-Mul itself isn't inherently malicious, its ability to make AI more efficient could inadvertently lower the barrier to entry for those who want to use AI for harmful purposes.
It's like giving someone a powerful tool without also providing them with a safety manual and clear ethical guidelines. We need safeguards in place.
Exactly. We need to develop robust security measures and ethical frameworks to prevent the misuse of AI, regardless of whether it's powered by L-Mul or other technologies. International cooperation and regulation will be key here.
It seems like navigating the ethical implications of AI is going to be just as important as the technical development itself.
It really is.
Are there any other potential downsides we haven't talked about yet?
One more that's often overlooked is the issue of transparency and explainability. As AI systems become more complex, it can be difficult to understand how they arrive at their decisions.
It's like having a black box. You put data in, you get an answer out. But you don't know what's happening inside.
That's a good analogy, and this lack of transparency can be problematic. Especially in high-stakes situations where we need to understand the reasoning behind an AI's decisions.
Like in healthcare, where an AI might be used to diagnose a patient's illness. Or in the criminal justice system, where AI could be used to assess the risk of recidivism.
Exactly. In those situations, we need to be able to understand why an AI made a particular decision. Was it based on sound logic and evidence, or was it influenced by hidden biases or faulty data? And because L-Mul works by approximating calculations, it could make explaining those decisions even more challenging.
So we need to find ways to make these AI systems more transparent. Even when they're using algorithms like L-Mul.
Absolutely. Researchers are working on developing techniques for making AI more explainable. But it's an ongoing challenge.
It sounds like there's still a lot of work to do, both on the technical side and on the ethical and societal side.
Definitely.
It's not just about building powerful AI, it's about building responsible AI.
That's a great way to put it. We need to approach AI development with a sense of caution and foresight.
Right.
Always mindful of the potential impact on individuals and society as a whole.
As we wrap up this deep dive into L-Mul, I'm left feeling both excited and cautious.
Yeah?
Excited about the incredible potential of this technology to solve problems and improve our lives, but also cautious about the need to mitigate the risks and ensure that AI is used ethically and for the benefit of all.
I agree. L-Mul represents a major step forward in the evolution of AI.
Right.
But it's crucial that we navigate this new landscape with wisdom and responsibility.
We need to have these conversations not just about the amazing things AI can do, but also about the potential downsides and how we can prevent them.
Absolutely. And to our listeners, we encourage you to continue exploring these issues. Asking questions and engaging in thoughtful discussions about the future of AI and the role it will play in shaping our world.
It's a future full of both promise and peril, and it's up to all of us to ensure that AI is used for good and that its benefits are shared by everyone.
I think that's a great place to leave it.
Thanks for joining us on this deep dive into L-Mul.